This video will give you some of the tools that you will need to be familiar with as we study chemistry for the remainder of the year. Some of the concepts in the video will be new to you, while some are probably already familiar. The first topic we're going to cover is scientific notation. The goal of scientific notation is to write any number as a number between 1 and 10 times the appropriate power of 10. Any number that is not written as a number between 1 and 10 times the appropriate power of 10 is not written in scientific notation. The number 245 is not written in scientific notation because it is not written as a number between 1 and 10 times the appropriate power of 10. The number 0.00054 is not written in scientific notation, nor is the number 1,367,000, nor is the number 0.1234. In order to put a number into scientific notation, if you have to move the decimal point to the left, the power of 10 is a positive number. We can see this in two of the examples from above. To write 245 in scientific notation, we have 2.45 times 10 to the second. The decimal point, which is normally located here, gets moved over 2 places to the left, so we have 2.45 times 10 squared. The other number that needs to have the decimal point moved to the left is 1,367,000. This number, written in scientific notation, is 1.367 times 10 to the sixth. That's because the decimal point, which is usually here, gets moved 6 places to the left, 1, 2, 3, 4, 5, 6, to equal 1.367 times 10 to the sixth. If you have to move the decimal point to the right in order to put the number into scientific notation, the power of 10 is a negative number. Two of the above examples are like this. 0.00054 needs the decimal point moved to the right in order to make it a number between 1 and 10. We must move the decimal point 4 places to the right to get 5.4 times 10 to the negative fourth. 0.1234 needs the decimal point moved to the right in order to make it a number between 1 and 10 as well. We need to move the decimal point 1 place to the right to get 1.234 times 10 to the negative 1. We'll talk about a number of prefixes which can be used to modify any of the base units in chemistry. The base units that we talk about are things such as meters, grams, seconds, etc. Any of the units that we're going to discuss here can be used as prefixes to modify these units. We'll talk about the prefix, symbol, meaning, and exponent. The prefix kilo, with a symbol K, means 1,000. The prefix hecto, with a symbol H, means 100. The prefix deca, with the symbol Da, means 10. We then have the base unit, such as meters or grams or seconds, with no symbol. The meaning is 1 with just the base unit. Deci, with a symbol D, has a meaning of 0.1 or 1/10. Centi, with a symbol C, has a meaning 0.01 or 1/100th. The prefix milli, with the symbol M, has the meaning 0.001 or 1/1000th. And the prefix micro, with the symbol mu, has the meaning 0.000001 or 1/1,000,000th. So if we say we have 1 kilogram, that means that we have 1,000 grams. If we have 1 hectometer, that means that we have 100 meters. If we have 1 centimeter, that means that we have 0.01 or 1/100th of a meter. If we have 1 micrometer, that means that we have 1/1,000,000th of a meter. Alternatively, we could think that it takes 10 meters to make a decameter, or we need 10 decimeters to make a meter. We see that these prefixes mean numbers that are greater than 1. So kilo, hecto, and deca are for numbers greater than 1. These prefixes, deci, centi, milli, and micro, are for numbers that are less than 1.